right, let's go ahead and get started. So I am the only thing standing between you and lunch right now. So this talk is all about working with geospatial data in the context of GraphQL APIs and specifically leveraging GraphQL-database integrations. So the slides are linked here. You can also scan that QR code that goes directly to the slide. So my name's Will. I work for a graph database company called Neo4j. Anyone used Neo4j before? A few folks, cool, great. Anyone using GraphQL with Neo4j? A few folks also. Okay, cool, that's great. So, you know, my job on the developer relations team at Neo4j is really all about helping developers build applications with graphs in Neo4j. And as part of this work, I worked on a GraphQL integration for Neo4j, ended up writing a book, Full Stack GraphQL Applications, which is available for a free download. If you scan that QR code, you can get the PDF of the book. And you know, it may seem interesting for like a database guy to write a book that talks about how do I use Apollo client, how do I, you know, use React, how do I deploy my front-end app to Netlify, but really like a database is such a core piece of your architecture that it's really, really important to understand how all these pieces fit together. I'm also really passionate about geospatial data and cartography. I'm very amateur cartography, rather. Very amateur, but these are some of the projects I worked on, mostly just for fun. If you don't follow this space, there's actually some like fascinating things going on in the geospatial data world, and specifically in cartography. So like, for example, Stable Diffusion drew that dystopian Smokey the Bear on that map of Sierra Nevada to Santa Marta National Park in Colombia. The shaded relief is actually drawn by a machine learning model trained on hand-drawn Swiss topo. So you can take a digital elevation model, pass it through that, and get this like beautiful shaded relief that matches what the Swiss masters have been doing. When I first started learning about geography, you learn about Tobler's first law of geography, which says that everything is related to everything else, but near things are more related than distant things. So let's apply that to an example. So Neo4j HQ is in San Mateo. That's like 5 miles that way, maybe. I don't know, I'm a little turned around. We're in Burlingame, it's pretty close. And so we can say that, you know, San Mateo is closer to Santa Cruz, San Jose, San Francisco. So those things are more alike than, say, like San Mateo and Minneapolis, which I was at for a conference a little bit ago. And we can quantify that, like, right? Like we know the distance between these cities. And what really like struck me and resonated with me is that this is a graph, right? This is how we think about data. And Tobler wasn't talking about just distance, by the way. He also meant things like human geography, how similar culturally are things, sort of well. So you can kind of bring your own distance metric to this. But graphs are really everywhere in the world of geospatial data. So if you're familiar with OpenStreetMap, this is, I don't know, probably the most valuable data set in the world, crowdsourced. Almost every mapping application uses it. Here's the OpenStreetMap data model. So we have nodes. These are your individual point features, so like points of interest or maybe like an observation in the middle of a street. And nodes combined together in ways can make up, say, like a street segment. We can group those in relations to make up, say, like multiple segments of roads for, I don't know, like an interstate or something like this. And if you look at this data model, this is also a graph, right? And so, you know, really we think about our data, and especially within this geospatial realm, in terms of graphs. But oftentimes when we go to work with GIS tooling with geospatial data, we have something more like this. So this is a screenshot from QGIS, which is a desktop GIS, geospatial information system for working with geospatial data. And this is from the Sierra Nevada to Santa Marta National Park map project that I used. I pulled in some data from OpenStreetMap to find points of interest, mountain peaks, things like that. If we think of how we work with data in sort of this like relational tabular format. Well, you have this attribute table, and each row has a geometry that basically defines, is this a point, line, polygon, this sort of thing. So if we're going to work with geospatial data in relational databases, kind of the gold standard for this is PostGIS or PostGIS, it's called sometimes. And this is basically spatial extensions to Postgres. And this implements something called the simple feature specification that adds these SQL functions, st underscore, that stands for space time, and you can do like st underscore intersection, find me features that intersect with this other feature, these sorts of things. PostGIS is really the gold standard for geospatial databases. So if I'm going to expose a GraphQL API on top of PostGIS, I'm going to use my favorite GraphQL integration for Postgres, which is PostGraphFile. You basically point this at an existing Postgres database, and you get a fully functional GraphQL API. And you may say, okay, cool, like that probably works with just bare Postgres, but that's probably not going to work with PostGIS. That's like some custom geospatial extension. No worries, Benji has us covered there. There's a PostGIS schema plugin for GraphQL that basically exposes the geometries and of our geometry column as sort of like a GeoJSON object within GraphQL. And there's additional functionality for things like filtering using some of those st underscore functions. So this is from a workshop at a conference called FOSS4G, which is a free open source for geospatial conference. If you're interested in specifically this, all the information or the code is on GitHub. It's a really good resource for learning how to use GraphQL with PostGIS. Okay, so that's a look at how we can build GraphQL APIs on top of Postgres and PostGIS. What about going back to this graph concept, right? So fundamentally, a graph is this data structure. We have nodes, these are the entities, they're connected by relationships. In Neo4j, we allow you to model, store, and query your data as a graph. We call this the property graph model because we can store arbitrary key value pair properties on nodes and relationships. We also have this idea of labels for a node that describes the type of the thing that it is. It's a way of grouping nodes together. You can think of it as, I don't know, roughly similar to like a table from a relational database. So on the left here, I have a diagram of an implementation of a property graph model. This is from the full stack GraphQL book. So the application we build is like a business reviews application. So we have users that write reviews of businesses. Businesses are in some category. We can also describe that same graph model using GraphQL type definitions, right? That's what we have on the right. So both of those are describing the same graph model. And you may wonder, like as a graph database, like what's the interest here in GraphQL? Well, if we observe that the data model that we're using in the backend in the database is a graph, and we have a graph data model in our GraphQL API, a lot of like problems of implementing our GraphQL API kind of go away, and there's lots of interesting things we can do. So the integration for Neo4j with GraphQL is the Neo4j GraphQL library. It's a JavaScript library that basically makes it easier to build this API layer that sits between the database and your client application. GraphQL is very much not a database query language. It's important, I think, to realize that and not try to move forward with that approach. It's all about making it easier to build this API layer that sits between the database and your client. So with the Neo4j GraphQL library, the basic idea is you take your type definitions in GraphQL, that defines your GraphQL schema, essentially, what data we're working with, how it's connected. We use that also then to define the property graph model in Neo4j. And the library will then generate all the CRUD operations, entry points based on all the types you've defined by default, things like ordering pagination, complex filtering, exposing the geo types that we're going to talk about today. So this example, this comes from a data set I've been scraping the New York Times. And so here we're looking for geos that are mentioned in articles in the New York Times that are within some distance of some point. And this is functionality you get out of the box, basically, just by defining your GraphQL type definitions. So then at query time, the library will take your GraphQL request and translate that into a single Cypher statement. Cypher is the query language that Neo4j uses. You can think of it as like SQL, but for graphs. And it's important to note, like, this happens at the root level resolver. So for any arbitrary GraphQL request, a single database query is generated. So that means N+1 problem goes away. The complexity of figuring out how to optimize a traversal is pushed to the database, which is really great for GraphQL, because in GraphQL, you often end up with these very nested selection sets describing a traversal through the data graph. That's exactly the thing that graph databases are optimized for, figuring out how to traverse that graph very quickly and efficiently. There's another feature of the Neo4j GraphQL library that I think is extremely powerful. So we talked about like all these basic CRUD operations, filtering, these sorts of things that you kind of get for free. Okay, what if I have some custom logic? What if I want to, in this case, find article recommendations? So what are similar articles to what the user is currently reading? If you're reading an article about hurricanes in Florida, I know you might also be interested in these other sort of like weather-related events, maybe also other articles about Florida, these sorts of things. And so there's a feature of the Neo4j GraphQL library that allows you to annotate your type definitions using the Cypher schema directives. So schema directives are GraphQL's built-in extension mechanism. And we essentially attach a Cypher statement to a field in our GraphQL schema. And now we have this logic that we've defined in Cypher that will run when we request that field, still embedded as one generated Cypher statement, sort of as a subquery. So super powerful feature. Here we're using the Graph Data Science plugin for Neo4j to look at Jacquard similarity. So that's the Neo4j GraphQL library. Again, focused very much on building that API layer between the database and the client. So you may wonder, how do GraphQL database integrations like the Neo4j GraphQL library and others work? How do they, under the hood, know like how to generate a database query from a GraphQL request? And basically, they do this by looking at what's called the GraphQL resolve info object. So every resolver is passed this object, and these database integrations hook into this object. And you can see there's a lot of information in here, but basically we have the selection set, we have the schema, we have the AST, the abstract syntax tree of your query. So we can essentially use that as sort of like a look ahead from the root resolver to see, okay, what are all of the fields requested, and iterate over that to build up a database query, a single database query at the root resolver, to go to the database with one round trip, one query to resolve our whole GraphQL request. Super powerful. I gave a talk at GraphQL Summit a few years ago, digging into this a bit more. So the recording is there on YouTube if you want to check that out. One thing that I'd like to clarify about this recording, the conference was on Halloween. I was wearing my Halloween costume. That context is lost in the recording. So if you watch that, that was not my everyday getup. Cool, so let's talk about spatial search, back to our focus on working with geospatial data. So spatial search, you can think of this as a few different options. So something like find points of interest close to some point, that's radius distance search. Find everything within a kilometer of some point. We can also do within bounding box. So if I define the so essentially two corners of a bounding box, what are all of the points of interest within that? Or more complex, I can have a polygon that defines some arbitrary shape. So here we're looking at a specific neighborhood in Burlingame. And these are all things we can do with Neo4j. When we define a point type in our GraphQL types and pass that off to the Neo4j GraphQL library, basically we get here we defined a location point type on our business. And so we get things like latitude and longitude fields for this point. So here we're just sort of saying, hey, give me 3 businesses and their name and location. But we also get geo-filtering as part of the where argument. So the where argument is how we pass more complex filtering. So here we're saying find all the businesses that are within 3.5 kilometers of some point. We can see here we get Hanabi, which is a ramen restaurant, Ducky's Car Wash, which is just down the street, and Neo4j HQ, which is also just down the street. We get into other more complex predicates here. So maybe I want to know, okay, what are all of the ramen restaurants within this geo boundary, maybe that my friends have reviewed positively, right? So really important for powering these sorts of geospatial-based recommendations. Okay, cool. So that was a lot of slides. Maybe let's look at a little bit of a demo here to see this in action. So a while ago, I put together a workshop on building a routing app with Neo4j. There wasn't anything specific about GraphQL in this, but this is the data set we're going to start with. So this data comes from OpenStreetMap. I think I pulled in San Mateo County from OpenStreetMap, and we have essentially like an intersection to intersection street routing graph, which is this piece here. And then we also added points of interest, so all of, I don't know, like restaurants, businesses, these sorts of things, also from OpenStreetMap, and hook that in, essentially find like, okay, what's the nearest intersection to this point of interest in our street grid. Also added addresses from Open Addresses as well. We're not gonna look at that. And then we built a little React app, or in this case, I think just a simple JavaScript app. Basically is like a very, very, very simple Google Maps. I can start typing in names of businesses I'm looking for and get the fastest route connecting them. So before we dive into how we can do this in GraphQL, maybe let's look at how we can do routing in Neo4j. So in this idea of pathfinding graph algorithms, there are a few different options here. The simplest one is shortest path. So this is like a binary breadth first search through the graph. I know my starting point, I know my end point, and hey, just find me the shortest path as measured by, in this case, like number of intersections that I go through. And in this case, we're looking at airports, so it's like number of hops of airports. But that's not often what we want. We want like the shortest distance, the least cost traversal. So for those, there's things like Dijkstra's algorithm, which takes into account the cost, or in this case, it's going to be the distance traveled. And you can see these different flight options. So all of these are going from San Francisco to Fort Myers, Florida. But here I get kind of a suboptimal route to pop over here and then come down. You can see with Dijkstra, I get a much shorter route. A-star is kind of an extension of Dijkstra, but we just sort of use a priority queue to choose which routes to explore first. So let's take a look at how this works. Here's Neo4j browser. This is like a query workbench for Neo4j. And this is a cipher statement. So we didn't talk much about cipher, so maybe it's worth just looking at what we see here. So cipher is all about graph pattern matching. So we're defining the graph pattern that we're looking for. You can see we're sort of drawing this like ASCII art representation. So within parentheses, we're drawing nodes, and then we have this kind of bracket with an arrow and kind of defining like a relationship. So here we're saying find a point of interest node, give it the alias 2, and then follow this nearest intersection relationship to find the nearest intersection in our routing graph, and then do the same for the from point of interest, find its closest intersection node. And then specifically, we're going to look for a route from the Burlingame Public Library. So I don't know, we've been there reading books, working all day, and we're ready to go to the Half Moon Bay Brewing Company. So we've sort of found our source and target nodes, these two intersections we want to route between. And in this case, we're going to use the Dijkstra's algorithm to find the shortest path between these two points of interest. And we get back a graph. So here's all the intersections that we're going to go through. And This comes from OpenStreetMap, so we have some information about, okay, we're going to take San Mateo Road to get there to this intersection, and we probably just keep going on San Mateo Road for a while. Eventually we go over the hill. I don't know if folks have been to Half Moon Bay. It's quite nice. So that's how that works in Neo4j, but we want to do this in GraphQL. So we're going to use a tool called the Neo4j GraphQL Toolbox. This is like a low-code kind of testing and development tool for building GraphQL APIs backed by Neo4j. This wraps the Neo4j GraphQL library. And we basically just point this at a Neo4j instance, either locally or running in the cloud. In this case, it's one running on my machine. We define our type definitions, or we can also just hit this introspect button if we have an existing database. It'll generate the schema for us. In this case, we've added just a couple of types. It's pretty simple. We have intersections. They're connected to other intersections. And we have points of interest. They're connected into our intersection routing graph by this nearest intersection relationship. So we hit build schema, and we can see here on the left, I've kind of pre-populated some queries so you don't have to watch me fat finger all of this. But you can see on the left, all the entry points. So this is GraphQL Explorer, which kind of gives us some nice point and click visual documentation for the generated schema. You can see sort of all the things that we have available here. And so the query that we're going to start with is let's find points of interest near the Burlingame Hyatt. That's where we are now. So this is roughly, this latitude and longitude is roughly where we are. We're going to say find points of interest that are within 500 meters of where we are now. And so behind the scenes, the Neo4j GraphQL library is going to generate a single database query, go to Neo4j, and grab that. So the first one is this plane spotting location. That's a fun activity. People go to the park and watch planes come into SFO over Coyote Point. It's actually very, very pleasant and peaceful there. Very nice. So, okay, that's cool. We saw an example of that already. We want to do routing, right? So let's go back to our type definitions. And I'm going to hit prettify. We have a little bit more hidden down there. So what we have here is a cipher directive. So here we've added, defined the query type, so a root level entry point to our GraphQL API. And I've used the cipher directive to attach some custom logic. And this is basically the query that we saw before, where we're using Dijkstra's algorithm to find the shortest path between 2 points of interest. The difference here is now that we're taking field arguments, a from and a to, and in the cipher directive fields, any field arguments that we define in our type definitions are automatically passed to the cipher statement as cipher parameters. So we can reference those as to and from here. And now, when we go back to build the schema, I'm going to go to our find route query. And in this case, we have a find route query field. And again, I want to find the route from the library back to the brewery. And what are we going to return? Well, we're going to return just the latitude and longitude and the OpenStreetMap ID of the intersection that we have. So we run that. Cool. Here's the shortest route. We can pipe that to our front end to render a nice view. Cool. So we've seen all these. These are my backup slides in case that demo broke. So a couple minutes left. I want to talk about a few resources that you can dig into if this sounds interesting. I guess the first thing is like, hey, if this sounds interesting, come see us at the booth today, next door. No, that way? Yeah, that way. This is what it looks like, except there's like friendly, smiling people here that you'll see. Come tell us, what you're working on if you're using Neo4j. We're raffling off some signed copies of the full stack GraphQL book. But definitely come chat. That's a really good resource. Like I said, the book, don't go buy it. Like it's free. There's a free PDF. Neo4j sponsored it, so you can download the PDF for free if that sounds interesting. There's all the code on GitHub. We also did a bunch of live streams walking through the exercises in each chapter, so it's kind of like a full course. There's also in Neo4j's Graph Academy, there's a Intro to Neo4j and GraphQL Graph Academy course that digs into a lot about what we're just talking about. I put together a spatial cipher cheat sheet a while ago not specific to GraphQL, but just covers a lot of the interesting functionality of things you can do with geospatial data in Neo4j. So that's a good resource as well. I think we also did a video for this one. Things like how to work with OpenStreetMap to do graph data science and analyze road networks, which is pretty fun. In October, we're going to do a hands-on workshop digging into, again, working with geospatial data and Neo4j. It's part of our nodes, or the Neo4j Online Developer Education Summit, which is coming up at the end of October. So definitely register for that if you're interested in learning more about graphs in Neo4j. And I guess the final note that I'd like to end on is, you know, we looked at a few different data sets here, and we saw graphs in them. And so really, graphs are everywhere. Once you start thinking in terms of graphs, you really do see them everywhere. And also, graphs are for everyone, right? Like, this is, I think, sort of intuitively how we think about data and how we think about how our connections to the world even. So I would just encourage you to bring that sort of graph thinking mentality, as in this case, we now go to lunch. So that's it. Thanks a lot. Come find us at the booth if you want to chat more. Cheers.